Welcome to the Explainer. So, today we're tackling a pain point literally everyone has experienced at some point. Those incredibly confusing user manuals that just make you want to rip your hair out. And more importantly, we're going to look at how we can completely fix them. Because, we've all been there. You buy a new piece of software or some shiny new gadget, you open up the documentation hoping for just a quick, easy guide, and bam, it's a wall of text that reads like an alien language. Well, by the end of this explainer, you are going to know exactly how to decode that user experience and create documentation that actually empowers people. All right, let's jump right in. So, let's start with a little mystery. Why is it that documents written by, frankly, brilliant product developers so often leave the rest of us just completely scratching our heads? I mean, the people building these tools are incredibly smart. They know every single line of code, every tiny button. But the second they try to explain it to us, there's just this massive disconnect. And as it turns out, the failure usually isn't a lack of technical knowledge at all. It's actually a totally wrong perspective. They're essentially writing from the inside out instead of the outside in. The root of this whole problem actually has a name. It's called function orientation. It's an approach that basically just systematically explains each function, each feature, or interface element of a product. It's documentation written exactly like a developer's spec sheet. So instead of focusing on what the user actually needs to achieve, it focuses entirely on what the tool is, literally button by button. It's written by and for programmers who naturally think in terms of required functions, not human goals. To really see the trap of function orientation, just look at this contrast right here. Telling someone the save button saves your project, well, yeah, that's technically true. And hey, maybe it's helpful to a quality assurance tester who's just going down a checklist of buttons. But it really doesn't help an actual user use the software effectively. On the flip side, phrasing it as how to save your project, well, that starts directly with the user's goal. It's such a subtle shift in wording, but honestly, it represents a massive leap in how we approach explaining things. Okay, moving on to section 2, the art of task analysis. Because to cure this whole documentation dilemma, we really have to bridge that gap between the machine and the human. There's a great quote that sums this up. To write in a task-oriented manner, you must first do some task analysis, studying how users use the product or do the task. Basically, you have to do the groundwork. Ideally, this means we actually watch users in action. We interview them, we chat with the marketing and product dev teams, and if you can snag the actual help desk tickets that frustrated customers are sending in, man, that is an absolute goldmine of info about what the user is actually trying to get done. But let's be real, reality rarely matches that ideal. More often than not, writers are brought in way too late in the game. Product developers usually aren't thinking about documentation until the absolute very end of the process. And in those situations, you probably lack direct access to the product team. They just don't have the time to sit down and thoroughly explain the product to you. So what happens? You end up having to rely on some educated guesswork. You basically have to become a detective. So let's put on our detective hats for a second and look at decoding the user interface. When you can't talk to the users or the developers, you've got to reverse engineer what the user wants just by looking at the software's interface itself. Because every button, every menu, every little icon, it's a clue. It's a clue left behind by the developers hinting at what they expect someone to do. And by decoding this interface, we can actually build our own task analysis completely from scratch. To see exactly how this works in practice, we're going to use this case study, a simple program called the AZ Icon Edit tool. This will be our primary piece of evidence. I want you to imagine you've just been handed this software, you have zero instructions, and it is your absolute job to write the manual. Where do you even start? Well, you start by looking at what's right in front of you. Just by quickly scanning the top-level menu options, the stuff usually sitting under File, we can immediately deduce a few obvious tasks. A user is clearly going to need to know how to start a new icon project, how to open an existing one to edit it, rename a project, and ultimately exit the program. Boom! Just from those basic menus, we already have 4 concrete, user-focused tasks lined up. Then, as we dig a little deeper into the drop-down menus, maybe under Edit or Image, a whole secondary layer of actions pops up. Now our detective work reveals tasks like undo a mistake, capture an image, cut, copy, or paste parts of the project, flip or rotate the image, and clear the project entirely to start fresh. And notice how we're framing these. We're not just saying the copy button. We're identifying the actual human task. Copy something out of an icon project. But of course, sometimes the clues are, well, a little less than obvious. For instance, what on earth does a mysterious restore button actually restore? Does it restore your file, your screen, your sanity? This perfectly highlights that disconnect between programmers and everyday users we talked about earlier. Some interface elements are just wildly unintuitive. To figure a task like this out, you might literally have to experiment with the software, ask around the office, or even dig into the programming specs. You absolutely cannot just assume the user will instinctively know what restore means in this specific context. Moving past the text menus, we also have to look at the visual icons. These give us entirely new physical tasks to document. So, for example, a wavy line icon pretty clearly means the user wants to draw freehand lines. There are icons for drawing rectangles and ovals, and look at that third one, a hypodermic needle icon. Okay, a little weird, but that's clearly for filling an area with color. Finally, a dotted line icon usually implies selecting portions of the image to move or edit. Every single icon represents a distinct user goal. So now we can take this big, chaotic list of raw clues, the pencils, the ovals, the weird needles, and we can actually map them into neat, logical user intentions. The needles and buttons become the task of selecting colors. The shapes become drawing. We're taking the messy interface and actively organizing it into a structured list of human intentions. All right, we've successfully gathered our clues, we've done our educated guesswork, and we've anticipated the questions our users are going to ask. Things like, how do I change the background color? Or how do I change line thickness? So let's pivot to the payoff, writing for the user. This is where we ensure all that detective work actually translates into a guide that a human being will genuinely love to use. The golden rule here is to use task-oriented phrasing. This means using action-oriented language designed for specific user goals rather than just naming the features. We have to completely drop the developer speak, right? We need to format our headings and subheadings with active words. It is literally the difference between labeling a section volume adjustment versus labeling it how to adjust the volume. One is a static thing, the other speaks directly to what the reader actually wants to do. You can really see the stark difference in approach here. Problem phrasing relies on static nouns, capture or oval icon. Those are just things sitting dead on a screen. But task-oriented phrasing uses active verbs, capturing images, or drawing ovals. And that is crucial because it allows users to scan the document, find their exact goal, and get started instantly. And once we have those beautiful task-oriented headings, we can build the actual guide. The ultimate payoff of all this analysis is delivering step-by-step instructions. This is where we really hold the user's hand. We figured out what they want to do. Now we just use clear, sequential, numbered lists to guide them flawlessly through the exact actions needed to complete that task. Here's what that actually looks like in practice. It's a simple, foolproof, 3-step instruction for drawing a rectangle. Step 1, ensure that you have selected the foreground color you want. Step 2, click the rectangle icon. Step 3, position the mouse pointer in the drawing area, hold down the left button, and draw. Notice how clear and simple that is? It doesn't just say, the rectangle icon draws rectangles. It gives the user a precise, completely achievable roadmap to success. So to wrap this up, I really want to reiterate this massive distinction. Product specifications are written by and for programmers. They're all about the required functions that engineers need to actually build the tool. But your task analysis and the documentation that comes from it, that is entirely about real-world goals for actual humans. A spec sheet tells you what a button does. A task analysis explains what a user can accomplish. And I want to leave you with this thought. Because the principles of task analysis, they apply far beyond just writing software manuals. They apply to how we teach, how we lead, and honestly, how we communicate every single day. So, I challenge you. Next time you're explaining something, really anything at all, to someone else, ask yourself, are you just describing the tool, or are you truly empowering the user? Thanks for joining me on this explainer, and I'll see you next time.